Welcome back to the InfoSec and OSINT show. I'm, of course, your host, Josh Amishav. Today we're going to talk about internet-wide port scanning with Robert Graham, the creator of Masscan. If you're into large-scale port scanning, you'll want to listen to this episode. Turns out I've been using Masscan wrong for years. My three main takeaways for conversation were 1, how to figure out the fastest rate you can send packets, 2, how to use the banner function correctly, and 3, the most common mistakes he sees when folks run Masscan. You'll enjoy those two things, plus a bunch of other tips along the way. And now, here's Robert. Robert Graham, welcome to the show.
Hi, glad to be here.
Thanks for coming on. So for those who perhaps aren't familiar with you, can you tell us who you are and what do you do?
I'm an old security researcher. I've been doing this since the 1990s. Back in 1998, I started a company called Network Ice. I made a product called Black Ice. It was the first intrusion prevention system, IPS, that ran on the desktop as kind of as a personal firewall on the desktop, as well as high-end corporate boxes that you stick on the corporate network at gigabit per second. It was also the first system in the IDS, IPS class that could do a gigabit per second. And so I sold off that company to Internet Security Systems back in the early 2000s, and then have been an independent consultant since then.
Okay, and at some point you created Masscan, which is an incredible tool. How did that come to be?
Back when testing the intrusion prevention system, one of the key problems was performance, that you had to gigabit per second. Part of that means things like high numbers of TCP connections per second being established. So I'd written a tool back then to sort of blast out packets at high rates in order to then simulate high numbers of TCP connections. And it wasn't really good for anything other than testing. It was, one of your early projects that are useful for you, but you've never done the work to actually make it useful for anyone else. So it would take more time to explain to you how to get around this problem in the tool than just me to go and fix 5 lines of code. I mean, it's at that stage of things where it's just useless for anything. Then in 2000, when was it, 12, 11, I don't know. I had started writing mass scans. I need to just make this into a port scan. I need to actually do what I did back then, but do it right. So I started writing mass scan. Then it languished for about a year, and then one day I decided to then finish it. So then I spent a month of intensive development effort just focused on just finishing it up and then putting it on GitHub.
Were there any other tools for mass internet-wide scanning?
Yeah. Dan Kaminsky had a tool, and I'm not quite sure what it did. There was also something called Unicorn Scan. I'm never quite sure what that is. Then there's a university project called ZMAP that they came out. Their technique was to use a kernel extension so that it would blast out TCP packets, but then any received packets, the kernel extension would then create a TCP connection within the kernel. The key thing about Masscan is that it has a separate TCP stack from the operating system. So ZMAP is an extension of the operating system's TCP stack, whereas Masscan is its own TCP stack.
Okay, what's the advantage of creating your own TCP stack?
That's a good question. The biggest thing is portability. Is Masscan works on Mac OS, on Windows, and on any sort of system. Whereas ZMAP, you have to sort of set up the system ahead of time to support ZMAP, and it only works on Linux.
How's Masscan architectured differently so that it's able to get results much faster than, say, Nmap?
All of these things, the way they do it is they spew out packets without caring for responses. So with Nmap creates a connection and then waits for the response. So, and to do that is fairly inefficient because you have all these threads or whatever, things waiting for responses and tracking the responses. With something like Masscan, it just spews out all the packets and it doesn't care about any responses. And if a response comes back, that's great. Then it will then do something with that response. So you can consider what happens when you have, let's say, infinite resources, but you're doing all 4 billion addresses of the IPv4 address space. Let's think that resources aren't a problem, but let's consider how many resources you would need. If you spewed out 4 billion, if you just established 4 billion connections, that means you have 4 billion records in the system waiting for a response. And it takes about a 1 kilobyte per TCP connection to have all the information for that TCP connection. So that would be 4 terabytes of information you would need a RAM just to hold a record for 4 billion TCP connections. So I guess when computers get even faster, we get 4 terabytes into our average desktop, that'll be a practical thing. But with Masscan, when you spew out 4 billion TCP connections, you don't have a connection record yet. You just spew out the packets. So the amount of RAM that you need is essentially zero. All you need is the list of IP addresses that you're scanning for.
Now, then how do you tie back the response then to know that, like, if you're spewing out tons of packets and you're stateless, then how do you keep track of what's open?
You use SYN cookies, basically. So SYN cookies was a technique to defend against DDoS, where when you send back a SYN ACK, so this is when servers get attacked by DDoS hackers. They get all these SYN packets coming in and trying to create loads of TCP connections. Well, they go into the stateless mode, and it's sort of a default now on Linux. You go into the stateless mode where you don't keep a record of the incoming SYN connection, but what you do instead is you craft the sequence numbers and the other information about the packet so that you can go stateless, so that when you get, and you send back a SYN ACK with that information, so that when the other party acknowledges the connection establishment, the third packet of the three-way handshake, you say, hey, I got an ACK, but it matches the other information in the packet, the port numbers and the sequence numbers all match to what would be a SYN cookie, which would map as if this had been a legitimate connection. So that at that point, they're able to establish the connections. So I use the same thing, but instead of for an incoming server, for an outgoing port scan, is that I set the sequence number and the source port numbers to be a unique combination that you're unlikely to guess as a legitimate connection. So you could flood Masscan with ACK packets or SYN ACK packets, trying to confuse it, but only 1 out of a billion will be accepted as a connection. And so that's how it does it statelessly. And it uses the same technique for a bunch of UDP packets as well, like with DNS requests. It sets the XID, the transaction ID field, and the source port to be a unique combination, and so on.
Interesting. How many probes are sent to each target for, let's say, for a random port? Is that a single SYN packet?
So Masscan sends a single SYN packet. If you want to repeat a scan looking for things you didn't find, you set a retry. You either run Masscan again or set the retry field. -- retries 1, 2, 3, 4. And the thing is with Nmap, you're often expecting a response from a target. So it's a reasonable thing if you're scanning just a few number of targets to do the stateful connection. With Masscan, your assumption is you won't get back a response from a target. So that you know that if you're scanning the entire internet for RDP, that only 1 out of every 100,000 devices will respond with RDP. So this idea of, well, I could, and you can do it with Masscan, is you can save a file for everything that didn't respond and then retry that. And just resend packets to everything that didn't respond to your first scan. But that's actually kind of pointless, because if you only expect 1 out of every 10,000 devices to respond in the first place, just scan everything all over again. And then you get duplicates, but so what? So ultimately, Masscan is built for not caring about what responded and what didn't respond.
And then on the flip side of that, though, how concerned should you be that a single SYN packet may get lost, and then you may want to increase the retry numbers? Would you suggest running Masscan several times just in case a single SYN packet was dropped and your results are less accurate?
Well, in all the studies I do, I do multiple scans anyway at different times, just because I know that an hour later, when I do the same scan an hour later, I'll get back slightly different results anyway. Again, for large networks, even simple things like people changing around network routes or flapping, or people are changing network equipment, on a large enough network, change is happening within an hour. So I don't want to resend a packet, 5 seconds later. I want to retry 5 hours later.
And then when you send the packet, let's say you send a single packet to whatever port, how long does Masscan wait for a response to decide if it's open?
Forever. As long as Masscan is running, it will accept a SYN ACK as long as it's running, because that SYN ACK has that cookie in it. And remember, I'm not waiting at all for any response to come back. Basically, Masscan, and you can actually do this. You can actually run 2 instances of Masscan. You have to use the seed parameter so they both have the same random seed. But you can run one instance that only spews out packets and another instance that only receives packets. For example, you have 2 different machines. The sender will spoof the address of the receiver, and the receiver just sits there sending nothing and waits for any response to come back. And then when it gets that SYNAC coming back that matches the random seed and the combination of everything, it will then pick up the TCP connection and start interacting with it.
Okay, and what's the use case for that setup?
That use case is for things like, let's say you have you go and get a burner phone for internet connectivity or something like that. Well, it used to work. These days it doesn't because they're all behind NATs. But in the old days, you could get, like on 3G, slow bandwidth, but phones that would have a real IP address, a publicly routable IP address. And you have a low bandwidth. So you can't spew out a million packets per second on that thing. But what you can do is go to some other serving hosting provider and spew out all the packets, spoofing the address of the phone. And then when the phone, it's only going to get back, 1 of every 10,000 packets or whatever. And so it can handle this on the low bandwidth to do the scan to receive it. So when the complaints come, complaining about being scanned, they don't go to the scanner because it's not using that as a source address. It goes to the burner phone address. So then they cancel your burner phone account.
Awesome. So what are the limitations that you come across when you do internet-wide scans? Like you mentioned, bandwidth be one of them. What are the other gotchas that you found?
Well, for anyone trying to do internet-wide scan, you have to find a provider that provides you that access. Because most of the time you'll get back complaints and then your provider will cancel your account. Another thing is people don't really quite understand the problem with small packets. The internet, we describe the internet in terms of bits per second. Like I have a 1 megabit connection or 1 gigabit connection. But the reality is that assumes bulk data, large packets, or streaming, or something where traffic is sent with large packets, at least 500 byte packets. But with Masscan, you're sending out 40 byte packets. And that stresses switches, routers, links. They're not really built for handling large numbers of small packets. So the packet per second limitation really impacts you. And this is particularly true with routers. The model of a router is that every packet is analyzed individually. But the reality is they look at the source and destination addresses and have cached routes in the router. So when a packet is received by a router, it doesn't look up the full router table. It looks up the streams that are currently going through the router and say, hey, I know that destination in a fast cache instead of the whole 1 million entries in the routing table, and it'll use that fast cache. Well, when you're scanning the internet, every route is an unknown route going out from the router. So it tries to that's not going to find it in the cache. And moreover, it's going to try to cache that route and then evict everyone else's traffic from the cache. So now when you're going through a router, you've taken down the router as far as everyone else is concerned. Now everyone's traffic, including yours, is going through the slow path instead of the fast path. And then everyone starts complaining and the ISP cancels your account, even though they don't know what you were doing. They just know that you're the source of the problem.
So how do you find a ISP or somebody that can allow you, that has the capability to do that?
It's been hard, and I found I use CarryNet, and we have good terms with them, good relationship with them. They have other scanner customers, like Shodan and other people, so they're used to high bandwidth outgoing stuff. They use Masscan as part of their testing for new routers. So when they buy a router, they'll run Masscan through it to make sure it can support it. By the way, it's just, it's going back 20 years, and Masscan is still one of the most effective ways to test network equipment. Because of the small packet problem of many different routes, many different connections, it will cause lots of network equipment to crash. And it's fun because I get people complaining all the time about this fact. It's like, oh my God, this equipment from Cisco or Juniper. And usually it's equipment that can handle it if you reconfigure things. And it's all sorts of complaints. It's fun.
But the vendors themselves are obviously not doing the same testing.
Well, I would hope so by this time. Vendors have, there's 2 roles for a vendor. For me, I want to test things to the limit. It's like when Boeing tests an airplane. They don't test. You'll get these videos online of Boeing breaking the wings of airplanes because they have this huge machine that puts more and more load on the wing of an airplane when they build a new airplane, when they design a new airplane. And the idea is it has to handle a certain load, especially when you're in the air and you're in a storm and it buffets and the plane drops 1,000 feet and then hits an updraft, then forces back up 1,000 feet. That's a lot of stress on the wing. So they have a machine that just puts a lot of stress on it, and it's supposed to support a certain limit without breaking. And you'll see these videos of where it bends more and more and more as more weight is put on it. But they don't stop once they reach the limit. They keep going until the wing breaks, and it always breaks when they do these tests. So that they don't know whether they've hit the limit, they know at what limit the wing will break. So network equipment is tested the wrong way. Is they say, well, it needs to handle a gigabit per second, so I'll throw a gigabit per second at traffic and see if it works. If it does, fine, I'll ship it. But what they need to do is we'll just keep increasing the load on it until it breaks, until things fail, and to know what that failure rate is. So send more and more packets, more and more connections, more and more new routes until things fail to understand it. So that's my philosophy in life.
Yeah, no, that's an interesting approach. Is there a way to, what is the right way to handle blacklisting? Obviously, you can't scan the entire internet without getting in a bit of trouble or upsetting certain organizations. But there doesn't seem to be at least that I'm aware of, a single list of avoid these IPs. So that everyone kind of does their own scanning and then has to create that list themselves, but then you can only create the list by scanning those IPs. So how do you suggest to handle that?
So it'd be nice to have a universal list that we all could use. But the reality is that the network is constantly changing. It's not really the organizations who get upset. It's some person at the organization who's in a job for the first time, suddenly sees all these scans, starts complaining all the time, and then a year later they're gone off to a new job. So you have a list and you're scanning the internet, you think you're fine, and then you start getting back these complaints. So organizations you've been scanning for years. And then a year later you stop getting complaints for them. So the situation is too dynamic to have this big master list. So I just maintain a list of myself of when people complain that they want to be added to the list, and I call it good.
Okay, so you got to maintain your own list. How do the banner feature work? Is that just it's opening up a connection?
So there's two ways to run a port scan, and one of which is all you care about is getting back which ports are open. The other thing is to get more information from the system. And one way to do it is just Masscan for the ports, get a list of IP addresses, and import that list into Nmap and scan a much smaller set of systems. But a lot of times you're looking for just very simple information. That's the banner of knowing like what version of the service is there, whether it actually is the service that you associate with the port, and other information like that. And that's where the banner check is when you add the -- banner to Masscan. So like with SSL, you get the certificate. With HTTP, you get the response back in the web page response. With SSH, you just get what's usually the version number of the SSH it's running, and so on. The first thing to know about banner checking is that on Linux and macOS, if you use the same IP address as the operating system, which is the default, banner checking won't work because the operating system also sees these SYNAC responses and then sends a reset packet. So then it kills the connection before banner checking can happen. Two ways around that. One way is to set a firewall rule saying whatever ports that Masscan are using aren't used by the operating system. So you can just go in and set a simple, just whatever firewall system you have. And that causes the operating system. So the TCP stack doesn't see the firewall ports. So with Masscan, by default, it chooses the operating system of the operating system. It chooses the IP address of the operating system and a random source port. But you can configure a -- source port and a range of source ports to use, and then so that in your configuration file, so that it can be consistent with whatever you set as the firewall rule.
Is there like a IP tables rules documented somewhere that people can like just copy and paste to have that set up?
I think on the web page on GitHub, there's an example setting IP tables rules of doing this. So if you go into the GitHub project, so it's pretty simple. You say, I want to filter out port 40,000, for example. And then you say to Masscan, use source port 40,000. And then you won't get back the TCP stack on the operating system won't see the response packets. And then you won't get the banners killed, and you can get into banner checking. The better option is, if you can, is just use a different IP address of your local network. Just look on your local network and say, find out which ranges aren't being used, and then just say source IP, that IP address. And then Masscan will use that instead. Then it won't conflict with your operating system or anything else. So Masscan is not simply spoofing the source address when it sends the packet. It also, when the response comes back and the router needs to find out where to send it, well, the router is going to ARP you and look for you. So Masscan will respond to the ARP packets as well. So it's not simply spoofing the IP address, it's actually using the IP address.
Very clever. You mentioned like Masscan will run a couple of different additional checks for like the banner or for the SSL certificate, but there's no like embedded scripting engine like NSC for Nmap. Is there any plans to add any scripting? Well, how do you suggest if you want to write your own exploratory extensions?
I keep meaning to get around to that and haven't gotten around to it. It will actually look for, I think I added enough Lua in there. Lua is the NSC scripting language. I've added hooks into Masscan to load Lua, but I haven't actually hooked in Lua into it completely for scripting. Another option is to just launch a separate program to then handle a TCP connection, kind of like the CGI scripts on HTTP. I keep think I need to get around to doing that. But other than that, you scan once, then use some other tools to scan the ports. It's like my RDP scan program. It's still used a lot for RDP. It contains the entire RDP protocol. I took an open source project, and then for RDP connections, client connections, and then mucked with it to look for certain vulnerabilities from Microsoft that were announced. This is like from 4 years ago or something. And then I scan the internet with Masscan for the RDP port, and then I use RDP scan on that list of IP addresses to then do the more intensive scan.
So as like a secondary scan after you finish Masscan, you'll parse the results, see if there's like RDP port open, and then run. And what you just RDP scan, so it looks for certain vulnerabilities, and then what else does it do?
And that's it. It just looks for the vulnerabilities.
Okay, and it's got some like exploit code to test to see if they're vulnerable.
It's not exploiting the vulnerability, but it's sending the packets necessary to see if it's been patched or not. Now, RDP scan also finds out more information about like what is it in the RDP system, because there's more information you can know about like what the operating system is and who owns it and other stuff.
Cool. Is there a good way or an easy way to figure out what the right rate of sending packets is?
This probably should be at the top of the Masscan page on GitHub. It's always hard because Masscan can easily go faster depending upon your operating system than the local network can handle. And when you go faster, the local network starts dropping packets. And you don't know where the problem is. Is it right out the port of your computer, or is it some link like a switch link or a router link somewhere slightly deeper into your own network? Or is it on the ISP side? Is it how many hops away? And you never know. And that goes back to the design of TCP. Is back 40 years ago, in 1980, there were two designs for network protocols, one of which is where the network would handle the congestion. And somehow all the routers would know, and they would send information back to each other about where the congestion was happening. But TCP was designed to be end-to-end, where the routers don't care about congestion. All they do is drop packets. That's the only indication you get that there's a problem. And it's the ends that are supposed to say, hey, my packets haven't arrived, I need to retransmit. And that's TCP. So Masscan doesn't know that packets are being dropped. All you know is that you're not getting back the responses that you expect, and you have to slow things down. And there's really no way of knowing other than, run 2 scans and then sort the responses and then diff them. And if there's a significant difference, then you're running too fast. That's how I figure it out.
Okay, how many iterations of scanning do you normally run?
Just 2. Just take 2, run the sort thing on them, and then do compare. And then there you go.
Okay, and then you wait a couple of hours between each run.
Well, if you're testing to see if you're significantly exceeding the bandwidth, you just do them back to back. because you'll get back, if you're dropping half your packets, then the difference in two back-to-back scans will be quite significant because you'll drop a different set of packets. So half of the systems you found in the first one will not show up in your second scan.
Okay, so just to make sure I understand. So the first scan you run, you don't put any rate limiting on the rate, right? How fast you're sending the packets.
Well, you run 2 scans with the maximum rate, and then if they're dropping packets, let's say half the packets are being dropped, the scans will be quite different in results. Only half the results will match.
Got it. Okay.
You can tell, hey, if only half the results match, then I'm dropping half the packets going twice as fast as I need to, and then you can back off from there.
Okay, and you slow it down, try it again,
right?
Run another 2 scans, check. Okay.
And though remember, so if the bottleneck is on your end, which is where it almost always is, then you'll quickly figure out the rate at which you could scan. Sometimes the bottleneck is on some farther area of the network. For example, when you're scanning a large network, you may have like a class B that you're scanning that's in a remote area. Well, it's that class B has 65,000 addresses, and they can quickly get overwhelmed, even though your rate is not exceeding your bandwidth. Theirs, because they had such a wide address space going to a certain sink, that they can get overwhelmed. So you can even though you're slow enough that your bandwidth can handle it, you may be still faster than this one subnet far distance to the network. So even when you do 2 back-to-back scans, everything may be the same result, except for this one subnetwork, which is chronically still having a difference in the results. So when you look at the result, the differences between 2 back-to-back scans, they look different when it's your network where's the bottleneck, in which case it's randomly distributed throughout which IP addresses, or when target subnets are having the bottleneck, in which case only that network is having differences between 2 scans.
Cool. Are there any common mistakes that you see when people run Masscan?
The biggest mistake is not appreciating the fact that they're running on a separate IP stack with the current IP stack. So that's why I always run it as its own IP address. That should be the default thing. Pick an IP address on your local network that's not your computer and not someone else's computer, and use that IP address.
And you need to do that even when you don't run the banner's flag.
You don't need to do it, but that for me is the preferred mode, because then it's a separate IP address. It's not conflicting, and yeah.
And you get more accurate results.
Well, sometimes it's the same result, but it just avoids potential problems. Like maybe there's an app on your computer that's using that port, that source port, just coincidentally. Probably not, but maybe there is. And then that app gets all confused and stuff, and it's just good just to have a separate IP address.
All right. Thanks so much for coming on the show. If people want to learn more about you, what you're up to, where can they find you?
On Twitter at Erratarob, ERRATAROB. My blog is blog.erratasec.com, ERRATASEC.com. And then just go to the Masscan page, github.com/Robert David Graham, which is easy to remember because if I'm like the most famous person among website administrators on the internet, because when Masscan scans, does a banner check on port 80 to a website, it uses Masscan. It mentions the GitHub address, github.com/Robert David Graham, as the user agent string. And so all these people just see in their logs several times a day, user agent with Robert David Graham /Masscan. So they know my name even though they have no idea who I am. I'm just some guy that appears in their web server logs. So that's where you can find any information about all my projects.
So either GitHub or your web server logs.
Yeah, github.com/Robert David Graham /Masscan. And if you forget that, just look in your web server logs.
All right. Thanks so much.
Certainly. My pleasure.
That's it for this week. Thanks again for listening and leaving reviews. If you have any comments or questions, I'd love to hear from you. I'm @Jamoose on Twitter, or drop me an email at podcast@breachsense.io. And if you're part of a security team that needs visibility into your employees, your customers, your third-party suppliers' breach credentials before criminals exploit them, head on over to breachsense.io to apply for a free 7-day trial. That's it for this week, and I'll be back in your earbuds next Thursday morning.